Hello, I'm David Botten, and today, in the coming days of course, we're going to be going through Common Lisp, the language, second edition, right, from Guy Steele. So what I'm going to be doing is I'm going to be going through chapter by chapter. I'm going to take the key information, things that I feel are important and that will highlight those pieces of information. We'll talk about them. Maybe we might do even a little bit more. But this is an opportunity basically to get some more depth into the Common Lisp language. So I hope you're ready for the excitement. You'll see there that I basically pulled up the page. You can actually just type the words Common Lisp, Guy Steele, and this will come right up as well, who of course is the author of this really de facto standard book of Common Lisp. And it is available online pretty much in various different formats. I took the PostScript version and made a PDF from it so that I could do the outlining that we're going to be using as we go through this. But the materials are available, and so I guess time to get started. We're not going to spend a lot of time today on much material, well, meaning actual practical type stuff. We'll go real quick through the preface, and we'll do chapter 1, the various different data types, and then we'll start working on our next video, and then it'll start getting more practical. This, of course, though, isn't really a practical per se course, right? Now, most of what I like to do is things that are hands-on, direct, but basically just to give us the theoretical language and the language itself, both for you and for me, to work on my knowledge of the lingo of Lisp, and for you as well. And that'll help us communicate better and help us be able to produce better and more advanced applications using the power of Common Lisp. All right, let's get started. All right, here we go with the preface. So first of all, this book itself was actually used as the standard for implementing Common Lisp platforms and Common Lisp environments, and for the most part that was the case until, of course, there is a real, actual, international standard. But nevertheless, this work is, of course, still one of the key places to be able to understand how to properly set up a Lisp environment. So while Common Lisp has been stable, it is not stagnant. That's just a reality. The language itself, the programmable language, continues to grow, continues to offer new insights and new abilities all the time. It is not stagnated in terms of what it can accomplish. It only stagnated in how much you have to know to be able to do amazing things. In fact, if you think about it, this is one of the key features, if you ask me, about Lisp: stability. The fact that it basically has not changed in all these years and still is as relevant then as it is now. It is an amazing language and essentially eliminates one of the key negative situations that exist with the fact that you're literally running after languages for day to day with brand new standards every year, every 10 years, whatever it might be. That this basically is a stable system that once you know it, and you can write a program now and years from now and still pretty much be in the same place that it's going to run. All right, so heading out to the introduction. Purpose. Well, purpose of Common Lisp as a language is to meet certain goals, and of course, commonality, basically to bring everything together into one version. And there's billions of Lisp, but really commercial Lisp, it's Common Lisp. That's just the reality of it. There have been some attempts to create languages that make people feel warm and smushy, thinking they're getting something modern. But the reality is that the Common Lisp essentially is the key workhorse of the Lisp family. They're all valuable. They're all good. But again, Common Lisp basically gives you that key thing. Well, commonality, portability. Right? They're basically almost every single platform in existence can basically use Common Lisp. That's just a reality. It's there's so many different versions that of implementation. So of course, great licensing on all of them. Both commercial and open source. Really, it's just unbelievable. Common Lisp basically can get the job done and get a job done wherever you are. Consistency. The bottom line is that this language has been. The best way to describe this is that when you go ahead and you're using Common Lisp, the solution that works is like always there. You know what I mean? It's essentially like they predicted what was going to need to happen in this situation, and they were there, and that's because they had years of really multiple implementations, working through all the kinks, and basically brings everything down to a single implementation that really works. Expressiveness, the language basically has got a very large library of functions. In fact, the people sometimes talk about the large size of the Common Lisp standards and so forth. But the truth of the matter is that's really the entire expressiveness that it has that goes beyond the language, that in terms of its built-in library. And the reality is that covers a huge swatch of what needs to be taken care of as far as the software. And of course, today we've got with Lisp and various other means to be able to quickly load together everything we need to be able to produce incredible software quickly, combining many different components. Compatibility, bottom line is that Common Lisp basically tries to be compatible with older versions, and that really doesn't matter so much today, since it's already so many years past. Nobody's making anything that isn't starting out in Common Lisp. But again, that was its purpose at the time. Efficiency, Common Lisp is essentially written and designed from the start to be an efficient language, and it truly is. In fact, believe it or not, is actually possible, and actually a reality that you can produce software that is faster than C. Go figure that one out. But that's just the reality. You can do that with Common Lisp. So essentially, you can get bare bones. There are multiple operating systems written in Common Lisp. I mean, listen, this is what it is. It's just that's what it is, and that's the power of Common Lisp and the stability of Common Lisp. And this is why I believe that this should be your next language. If you're just looking at Lisp now, or for that matter, you've already got a taste of the power. You're trying to learn more, and I'm telling you, it's worth it. It's worth it. Spend the time. Common Lisp was good then, it's good now, and it'll be good for a long time to come. Okay, notational conventions. Even though that's the case, it's really just to give us an understanding of some things in the book. I really found this section works to get some key information in quick. The symbol nil is used to represent both the empty list and the false value for Boolean tests. An empty list may, of course, also be written as two parentheses, meaning an empty list. This normally denotes the same object as nil. Right? Some weird exceptions where that's possible, but almost everything is the same. You can actually literally replace nil or the parentheses and they mean the exact same meaning. When a function is said to return true or to be true in some circumstances, so that means to say that it returns some value other than nil, but not necessarily true. So that means to say that everything is true unless it's nil. Okay, evaluation. This symbol, right here, this little arrow symbol here is used in examples, basically to show that we're going to result in an evaluation. Now, it happens to be this is used in this book and used in many other books as well. So plus 4, 5 equals 9, right? That's the evaluation. And like I said, that's a very common thing in all kinds of different Lisp books. All right, the Lisp reader, and of course, everybody knows the term REPL today, right, which is read, evaluate, right, print, and then loop back. So this is referring, of course, to the reader portion, the R portion. There's actually a function, read, which is used by the Lisp environments to read in the information into the Lisp image. And basically what it does is it reads in the characters from an input stream and interprets them by parsing as representations of Lisp objects. So that's what's meant by reader when you see it pretty much everywhere. All right, so let's start on our second chapter, which is data types. So in Lisp, it is data objects that are typed, not variables. So actually, Lisp is a very, very typed language. It's just that the variables aren't what's being typed, it's the actual information itself. So it's possible to make an explicit declaration that a variable will in fact take on only one or a limited set of values, which means to say it is possible to kind of, at least tell the compilers a hint as to what the variable should contain. And of course, that kind of, in fact, some implementations like SBCL actually make very heavy use of it to almost give you a really tight, good static type of environment for static typing that's actually on the variable, which is pretty cool. And so it is possible to get the advantages of a static type of situation, but you essentially can choose that. Now, the reason why it's called a hint is because if you remove all the hints that say which variable that will only receive a certain type of of content, which is really just things used for performance gains, for efficiency, right? That's what the declare statement does, is it says this and this and this can only be used this way, so the compiler can make assumptions about it. But also the compiler then could also tell us when this situation would be violated in advance. So like I said, it offers us a lot of advantages. Just keep that in mind. Like I said, when it comes to Lisp, it's the data, not the variables, that in fact have the types. At first it seems like, well, again, with the extreme, super type-centric situation that most people have come to, love for good reason. But actually, let me tell you, the efficiency of Lisp, by not being in that particular boat, being able to add later on that specific those specific checks when necessary, and also the fact that Lisp has this incredible dynamic development cycle that really eliminates a lot of errors early on because of the fact that you're not waiting for compiles and things like that. And again, just a general approach. It's not necessity that it is in other languages that essentially the variables contain a type. In fact, the opposite is actually what's even a feature of the language itself. There is a predicate, type P, which may be used to ask, right, whether an object belongs to a given type. So you say, well, type P if it's this one or this one, and that'll give you the answer. Type of basically gives you a type to which a given object belongs. So it's possible to use the type of to find out what the primary type is, and of course type P to find out if it matches any one of the various different members of a hierarchy of types, which of course is the case by Lisp. Lisp has a big hierarchy system where types are derivative types. In fact, it's very object-oriented, even before object-oriented was a thing. Okay, so basically the key high-level types that are in Lisp, of course, numbers, characters, symbols. Now, symbols are real types in Lisp, unlike other languages. Sometimes referred to as atomic symbols, right? And basically, it's a named data object. So basically, it represents various different things, such, for example, it has a property list that's associated to it. So this symbol, and you can associate all kinds of different properties about that symbol. There are the symbols themselves are used to represent functions and variables. And we're going to come across that quite a bit. In fact, that's the symbolic processing idea that is talked about with Lisp, and it really comes in far more handy than you would ever possibly imagine. It's like I said, we'll talk about it when we get more in depth in it when it comes up in the book. Lists are sequences, right? And arrays, of course, are dimensional collections of objects. Vectors are single. We'll talk about it just a little bit. Hash tables, again, like I said, in other languages, these are dictionaries. This goes to this, and Lisp is very flexible how the hash tables work. As far as what the keys are and what the values are, because there is no type, so it doesn't really care. You can manage to build up hash tables using just about everything. Path names are actually a specific type in Lisp. Interestingly enough, they're not just a string that contains the path of some file, but rather that's an implementation. Internally it's implementation independent of how it's set up, but basically there is a certain interface to work with path names. Again, something that we will discuss. Streams, basically sinks of data. Again, we're all familiar in almost every language with various different I/O streams and so forth. Again, we'll talk more about them when the time comes. Structures, of course. Well, structures are abstract data types that allow us to maintain compound structures of other information, like pretty much just about anything. And you can kind of build types just with structures alone, of course. Since Common Lisp is completely object-oriented as well, so therefore you can use structures and you can use classes, like I said, this particular work will talk about both. Functions, of course, symbols point to a function, or essentially give name to a function, and we'll talk about more of that actually really in the next chapter. Conditions. So basically, one of the cool things about Common Lisp is, again, it has a really great exception system, and exception is, of course, the wrong word. It's a condition system, because in Lisp, conditions can be used not just for exceptional situations, but also as a means of flow control and various, granularity of things that can be done with it that are far beyond the regular exception and error situation. And again, that's something that we'll discuss as well. much later on. Classes that we just mentioned before. Again, it's part of what something is called CLOS, which is the Common Lisp object system, and again has a lot of great features that again we'll get to it when we get to it. Methods. Now, methods are not functions. Methods essentially are bundled into generic functions, and we'll talk about that. What happens is that the way that the methods work is you write a function that basically, when you call that function, based on the types contained in the variables, in the various different parameters that are fed, basically it will then choose which method then to run. So what happens is, you imagine you don't really call methods, you call generic functions, which then choose which method at runtime to choose to use. And again, we'll talk a lot more about that, of course, when we're dealing with the object system later on. Okay, so numbers, integers, ratios, floating point, complex numbers. These are the various divisions, and there are more, but these are the key divisions, essentially, of numbers in Common Lisp. Now, the representation, and this is some cool stuff that Lisp has going for it. Basically, to write a binary number, you'd use a £b, right? £r, you can essentially feed in here. In fact, these two are equivalent, right? But what happens is, So basically, what happens is the two basically is a radix. Any radix at all can be replaced in order to be able to express it. So £2 would basically mean binary, just the same as the b. £0 for £8 radix, right? Therefore, that's an octal. Or X for a hex, right? And essentially, as you see here, that's the means by which you can express various different radixes of numbers of integers, specifically in Lisp. There's a real neat type called ratio, right? Which you don't have in any other language. There might be some of them, but the ones I generally use. Essentially, basically you have your numerator and denominator, two different numbers basically over each other, and that creates a rational number that can be expressed actually, in that form, right? Okay. Like I said, here's how you can mix the various different radixes with the ratios. Okay, floating point numbers are basically of type float. I'm not going to go too much detail. Most people are familiar with. There's long floats, single floats, double floats. All right. Let's see here. Okay, complex numbers. Type complex. They're written Cartesian form, real part and an imaginary part, and that's basically how they're written, right? So for the most part, like I said, you can form your imaginary numbers. Okay, characters, right? So again, that's the character type. Basically, the way you express a character, if you want to pick the is a pound and in the slash there, followed by a character itself, right? So if you want to say the character G, that's how you would write it to represent the character. There is, interestingly enough, no specific way to character slash, again, with an ASCII value or something along those lines. I understand the reasons. It's a shame, but there are ways, of course, obviously, to still represent them, but not directly in the reader, right? Which is we're trying to write our code. We actually have to use a function or a macro to be able to produce them. Okay, anyways, that doesn't matter. No point in that. But like I said, there are some ways, and you'll find that there are a number of things we'll see in a moment. As an example, like if you want to represent the space, you can actually just write out space, again, with the little character expression to mean the space character. New line is very similar. New line is pretty cool because it actually allows the handling of pretty much, like I said, it allows the handling not just of a character turn or character turn line feed, but there's one or two. In other words, this is sort of a quasi representation that is only one character to your list system. And these following symbols are actually fairly standard character symbols: backspace, tab, line feed, page, return, rub out. New line we just mentioned, an implementation of Common Lisp must translate between the internal single character representation and whatever external representation may be used. All right. Okay, so symbols, as we said, this is a full-out type in Lisp. So symbols, they serve purposes. So, right, he says they have certain characteristics. Symbols has a name, of course, called its print name, right? So the print name can go back and forth in terms of using the character strings and so forth, but that's not the idea. The idea is that the symbol itself has a value in itself. It's not the string value, but the value in itself, and it's very efficient how it's stored and used in a Lisp system. For example, in C and enum, that essentially gets close to what a symbol is, but a symbol is actually far more powerful. For example, you can actually a symbol itself can have an entire sort of almost like its own database connected to it with a property list. And symbols themselves, of course, can represent all kinds of variables and functions and things like that in Lisp itself. A symbol may have uppercase letters, lowercase letters, or both in its print name. Right, so it's actually possible that sometimes people think the Lisp actually has no concept of lower and upper, but it actually does. What happens though is a Lisp reader normally converts lowercase letters to the corresponding uppercase letters. There are ways around this, which basically, if you can escape characters and say to the Lisp reader, don't change what I'm going to hand you, right? Basically keep it literal. Use this character, lowercase character, uppercase, whatever it is, and regardless of what sort of changes might be done normally by the reader, they'll be left alone and ignored for a single character, the one that comes after the slash, right? So there's actually a more efficient way for doing a lot of characters in one shot, which basically means you use vertical bars, and everything in between the vertical bars will be taken lower, upper, taken literally for exactly the same way that you wrote it there and stored. That is the symbol name. So this particular symbol, if you actually wrote in this into your REPL, it's actually not going to find this because it's going to be looking for this, right? So that's the reality. So, but again, and this does actually have purpose, in some of the libraries for database access, things like that, they'll use symbols representing the various names of the fields, and they will keep things case sensitive, and that's the way you make sure that everything stays case sensitive in a symbol. Lists and kanzas. Right, so a kanza is a record structure containing two components called the car and the cater. Right, so a list, right, is essentially a chain of kanzas terminated by nil. Right, so again, we're not really doing a course on Lisp, so I'm not going to get too much into it, but that's the basic definitions. A dotted list, right? Basically, this dot notation, and that's an actual dot that's there. And that's supposed to be there. That represents. Again, I did the same thing. So what happens is the dot lets you know that basically this is not really a list. It's just a cons with two values. Now this, right? This is actually a Lisp that does not end with nil, so it's not a true Lisp, but rather it's a chain of kanzas with the last value being, in this case, a D, rather than being a nil. And the way we can identify that is, again, this little dot here in the middle of our list. All right. Let's see. A true list will be used to refer to a list terminated by a nil. That's the point. That's a true list. Okay, arrays. So a number of dimensions of an array are called its rank, right? A array rank limit says how many basically ranks will be allowed in your particular implementation. It's permissible for a dimension to be 0. In this case, the array has no elements. And actually, like I said, later on we'll talk about how to access and use hash tables and arrays and things like that when we get to them. Like I said, this is really all just about the data types themselves, but multi-dimensional arrays store their correspondence in row major order. All right, so keep that in mind if you're, I'm not going into details with that, but it's important to know when doing more systems level programming. One-dimensional arrays are called vectors. right? So we have an array, but when it's one dimension, it's a vector. It's exactly the same thing, just a one-dimensional array. There is, though, a way, a shortcut for the reader for being able to represent, right, a vector, and that is essentially create the list and start it with a pound. So that means everything in here is actually a vector as opposed to a list. Okay, so read parses the syntax and makes use of it. There is no syntax for hash tables, but for vectors there is. All right, and also multi-dimensional arrays. I don't know. I don't think the reader has a means to achieve entering them that way either. Okay, but again, we'll get to that when we get to it. So string is simply a vector. That's another thing. Strings are basically just a one-dimensional array, a vector of characters. Right? And basically a string can be written as a sequence of characters contained in the string, preceded by and followed by a double quote. You can use a slash to quote the double quote, and of course a double slash to quote the slash, and that basically allows you to be able to do something like that, where again whatever follows a slash is taken to mean literally a quote. So there you go. So that's quote APL 26, everything else. Okay. The leftmost character is string element number 0, and that's the case, by the way, with arrays and vectors where they are 0 based. The next one is the number 1. All right, bit vectors. Now, that's interesting. This is a special type of vector that essentially creates a series of bits. Right, so it's actually less than well, it's like I said, a bit vector. Okay. Hash tables we mentioned. There's nothing really about names we mentioned. There's nothing specific in this particular run through that we're going to go. Unreadable data objects are represented, right, with basically the reader will print this out, or the printer will print it out, right? When a value basically can't be represented, and of course the particular class or particular object, whatever it is going to sometimes spit out some information to identify to us what that is. So like a stack pointer and where it is and so forth. The detail may or may not be useful. That depends on how it was implemented and whatever the case might be. So that when you see that this notation, that's something that can't be read in, but something that was basically pumped out and with some information that may or not be useful to you. Okay, so the type true is a supertype of every single type. Remember I mentioned that it was a hierarchy system. So true actually represents every type, right? So every object is of type T. Nil is a subtype of every type, right? Sorry, is a subtype of every type, but no object is of type nil. Right? That's just the way it works. Let's see. So the type null is a subtype of symbol. The only object of type null is nil. So that's a very unique thing about nil, is that it is null. All right, and string is a subtype of vector, which means that if something takes a vector, you can add a string. If it's an array, a single dimensional array, you can use a string. All right, and any more to do? So well, that concludes for today.